Hi, let's do an interesting chemical experiment today. This is an experiment that can make the candle go out and the water level rises automatically. How exactly is this done? Okay, first let me introduce the experimental materials I used.
The materials I used was a candle, a lighter, a glass, a transparent colored tray, and paint, which was to dye water into another color so that we could see it easily. The experiment was designed on the principle of Gill-Sachs law. Let's take a closer look at this principle with a floating candle. Okay, the first step is to add tap water to the tray. If you want the experimental effect to be obvious and dramatic, add a little more tap water into the tray. I think that's enough water. The second step, add the pigment to the water. And then mix it with the water to make the water blue. So now the paint is well mixed with the water, so I just used pigment instead of food coloring. So the third step is to place the candle in the center of the tray. Step 4. Light the candle with a lighter.
A final step, cover the candle with a glass. Make sure the candle is in a closed environment. Wait for the candle to go out and watch the water position change. First try. Watch the candle. The flame will shrink until it goes out and the water level in the beaker begins to rise. And it continues to rise a little after the candle goes out. The water level in the beaker is much higher than that in the tray. When a candle burns, it reacts with oxygen and the product is water vapor and carbon dioxide gas. As more and more water vapor is produced, it forces the candle in the glass to burn lower and lower until it goes out. Second try. As the flame goes out, the iron molecules under the beaker begins to cool. The temperature drops and this causes the magnitude of the pressure. Our air molecules drop as the pressure drops. The pressure inside the glass hopefully equals the pressure outside the glass.
Third try.
Okay, in this experiment, our beaker is filled with air molecules that disperse, move quickly, and excite energy when the pressure inside the cap is raised by burning a candle. But the volume stays the same because the glasses don't expand like a balloon. So, air molecules push harder and harder against the walls of our glass and the water at the bottom of the glass, causing an increase in pressure to push the water level at the bottom of the glass up. The volume of an ideal gas with a fixed amount or mass remains constant and the temperature is proportional to the pressure. That means that when it is a gas and the temperature increases, its pressure increases. The temperature goes down, its pressure goes down.
When the volume of a given mass of gas is constant, the pressure of the gas is proportional to the absolute temperature. I will operate this experiment in the bathroom to ensure the safety of the